Hello everyone, my name is Kato Collins and this is my final AI taxi fare prediction project that I've been working on throughout the semester. To start right away, these are the contents that I'm going to present. They include introduction, background, and motivation literature review. We shall look at supervised learning and unsupervised. Then we shall do our model, we shall describe the data set. Before that, we shall do exploratory data analysis. Yeah, and a lot more. So introduction on this project, a brief introduction. In Uganda, there is a large population of about 25% that uses taxi on a daily basis. This is because most of the individuals do not have private means or cars. Therefore, there is high demand of taxis, which has led to an increase in the number of taxis, especially in the urban areas. So some transport means are not user-friendly. We have problems with these transport means. They are not user-friendly, like taxis, which at times are congested. There are people who are hit with sickness and they require a quick drive to the hospitals, and they cannot access these means quickly, so they don't cope up with emergencies. So the model will be an artificial intelligence. And artificial intelligence is a simulation of human intelligence processes by machines, especially computer. So supervised learning is an artificial intelligence paradigm for problems where the available data consists of labeled examples, meaning each data point requires features as an associated label. Unsupervised learning is the opposite of supervised. In unsupervised, there is no labels on the data. So the background and motivation is the study was conducted on taxi transportation in urban areas of Uganda. But we find that this transportation is faced with vast amount of challenges, as I've described some. There's unfair charging of fares, inability to cope with emergencies, and many others. So prediction of taxi fares is unfair to passengers, and information on fare changes spread slowly, and so many are inconvenienced because they are stuck with old fares. So also long distance journeys at times require one to use more than one taxi, which increases the fares in some way or the other. But now this model we are coming up, someone can book it and they are able to move to their destination from the pickup point with only one taxi, which is not the case with many people who move through long distances. So literature review, we have taxi fare prediction has been a popular topic in the field of artificial intelligence, data science, and machine learning due to its practical appliances in transportation and logistics. Many studies have been conducted to improve the accuracy of taxi fare prediction models, and various approaches have been explored. This research aims to observe predictive evaluation, which is a method of analysis in machine learning. Many corporations we've seen like Ola, Uber have deployed this. So a survey suggests that the flight and cab fares vary in step, which different factors like place, time of the day, and so forth, cabs as well. Unsupervised learning techniques to come up with models that can reach our objective of fare prediction as well as supervised. So supervised learning, as we described, machine learning paradigm that has data that consists labeled examples. So we have several techniques in supervised learning. We have regression, which is a mathematical approach to find the relationship between two or more variables. These are one of the techniques we shall use, shall rely on regression. Then we have classification, which is a technique used to identify the category of new observations on the basis of training data. Unsupervised learning is a machine learning paradigm, which is an opposite of course, supervised for problems where the available data consists of unlabeled example, meaning that each data point contains features only without any associated label. So we have clustering as a technique in unsupervised, which is a way of grouping the data points into different groups. We also have association, which is a rule-based machine learning and data mining technique that finds important relations between the variables. And we describe these in relation to our project, a taxi fare prediction project. So we have the AI challenges encountered while using existing supervised learning. We have data quality and quantity. The performance of supervised learning models heavily depends on the quality and quantity of the data used. So you have to have a lot of data such that you eradicate bias or you reduce bias. We have overfitting, occurs when a model is too complex and fits the training data too easily. Underfitting is the opposite of overfitting, where a model is too simple and fails to capture the underlying patterns in the data. Feature selection. The selection of relevant features is critical for the performance of regression and classification models. However, selecting the right features is a challenging task and can require domain expertise. Imbalanced data. Imbalanced data is a common problem in classification tasks. So we have also challenges in unsupervised techniques. We have determining the appropriate number of clusters. We saw clustering as an example of unsupervised learning technique. We have selecting the appropriate distance metric that is in relation now to our project called taxi fare. Dealing with high dimensional data, clustering algorithms can struggle with high dimensional data where the number of features is much greater than the number of data points. Identifying the appropriate association rules. Solutions selected and implemented to eradicate some of the above challenges: collecting a diverse and unbiased data set, regularizing the model by adding penalty terms to the loss of function, adding more training data, selecting and engineering relevant features using assembling techniques. So our methodology, the problem being investigated is how to accurately predict the fare of a taxi based on various factors such as distance, time, location. These are our features in the data set. So the significance of this problem is that it can benefit both the customers and taxi drivers by providing fair and transparent pricing for taxi rides. AI is addressing this problem by utilizing machine learning algorithms that can analyze large data sets. So we shall see linear regression, which is a methodology we selected and implemented, though we implemented other methodologies that we shall see later, like random forest and others, supervised learning techniques. So linear regression, specifically, we relied on supervised learning techniques. We didn't use unsupervised learning. Data collection, collecting data on taxi rides, including the fare, distance, time. Data pre-processing, so we are looking at the process for linear regression. That is our methodology we picked. We have data collection, have data pre-processing, that is cleaning and preparing the data for analysis. We have model training, using the prepared data to train a linear regression model, which involves estimating the coefficients that best fit the relationship between the dependent and independent variables. So model evaluation, assessing the performance of the model that we've made on the separate data set, the evaluation data set. Model deployment, using the trained and evaluated model to predict taxi fares for new rides. So we used rule-based reasoning. This is also part of the methodology. The methodology we shall apply, rule-based reasoning, emphasizes knowledge transfer from an expert to a computer. As a consequence, the computer has to be able to find solutions to problems that otherwise should be solved by an expert. Knowledge is represented in the statements in the if a given action occurs, then a corresponding measure is taken in such a way that the line of reasoning can be explained. So we described our data set. Others has features. We have the size of the data set, a larger data set, factors that we considered when choosing this data set were size of the data set. Larger data sets can help improve the accuracy of our taxi because our taxi fare prediction, because it eradicates or rather reduces bias. Data quality, it is essential to have high quality data relevancy, data diversity. So we explained some of our features. Fare amount, which is the amount to be predicted for a taxi, right, depending on other features. We have pickup longitude and pickup latitude. These are geographical estimates, and together their intersection forms the exact pickup point of a passenger. Drop-off longitude and drop-off latitude, geographical estimates of locations, and together their intersection forms exact drop-off point for a taxi ride. Pickup hour, this is the time passenger is picked from the pickup point. Pickup day, pickup month. Haversine distance, this is the distance in kilometers from the pickup point to the drop-off point. Passenger count shows the number of passengers that are picked on every taxi trip taken. Below you can see a diagram of our data set. Data preparation and exploratory data analysis. So this is where we did our cleaning of the data. So the process we passed through here was removing duplicates. We checked the data set for any duplicate rows and removed them. Handling missing values, we checked the data set for any missing values. It did not have any. Checking for outliers. These are values that are significantly different from the rest of the data. Fix data types. We ensured that every data that was in it has the right data type it's supposed to have. Feature engineering, we created new features like the haversine distance from the drop-off longitude, drop-off latitude, and the other features of pickup latitude and pickup longitude. So feature selection, machine learning, known as an attribute of variable selection. So here we selected our features. So here you can see a diagram of a correlation matrix of our data set. And the correlation matrix shows the high correlation among variables. According to the matrix, all the independent variables are important for the prediction variable as they all contribute to it. Other analyses are also present. So we have outlier plots. We have a haversine distance here against density. We also have a box plot that shows the passenger count. It shows that most of the times the highest number of passengers, or rather most of is 1 and 2, but mostly 2. So it's rare to get above 3. Yeah, rare cases. AI evaluation metrics have accuracy, recall, and precision, then F1 score. Classification accuracy, the ratio of the number of correct predictions to the total number of input. So accuracy is the most intuitive performance measure, and it is simply a ratio of the correct predicted observations to the total observation. Recall is the ratio of correctly predicted positive observations to all observations. We applied all these in our projects: accuracy, recall, and precision, and F1 score. Dataset splitting. So we split our data sets into 3 sets: the train set, which was used to train our model; the test set, which was used for testing whether our model can predict tax fares; and the validation set for evaluating our model to check accuracy, errors, and variance score. So our train set took 60% of the original data set. Our test set was 20%, and our validation set was 20% as well. So AI model selection and optimization, we used several methodologies, or rather algorithms. We used support vector regressor, XGBoost, and linear regression, as I explained earlier. So AI model selection accountability refers to the responsibility of individuals and organizations for the actions and outcomes of artificial intelligence systems. Model evaluation. So we evaluated our model refers to the process of confirming that the model achieves its intended purpose. We evaluated our model on the validation set, which was 20%. And after evaluating our model, this is what we got. That diagram shows how our model works. With results and discussion, we evaluated our model on the validations data set. For evaluation, mean absolute error and root mean square error are recommended. So mean absolute error is the average error rate, which is the difference between the original value and the predicted value. While root mean square error is the error rate by the square root of MSE. So you have here diagrams, but we have a condition which says if the root mean square value is low, then that algorithm is the best. So according to our diagrams, it shows that XGBoost has the lowest root mean square error, and so it's rather better to use it than SVR and linear regression. So after training and testing, the results shown fairly, we reached the conclusion that XGBoost is the best because it gives more accurate value as compared to SVR and linear regression model. That is why XGBoost technique is the best to fit the model selection as it has lower RMSE value. So these are links to our Python source code, the notebook, and this is a link to our dataset that we used. You can click on them and you get them. Thank you so much for listening. Yeah, we meet next time in another project.